Thanks for the great work and presentations. I was just wondering about the device personalization. So, because goggles will be very useful if they are personalized to the user's taste, and so basically there will be some sort of federated learning or something or some type of on-device model training. But eventually, we want to secure all that information, even if user wants to change glasses, like we change phone every year. So hopefully users will change glasses every 6 months. So because we are in Qualcomm and we want to sell hardware. So considering that, where will that model be stored, and if this is already discussed?
Yeah, there's probably a few of us that could just come up in this direction. So I think there's the high level answer I'll give, and somewhat personal answer, but I think there's a paradigm shift needed in the concept of models and essentially your digital ID that extends way beyond kind of the current credentials that we're used to authenticate to get into your bank account or even your email, etc. And so certainly for people who are interested, then the push towards distributed or decentralized data stores like Inrupt and Solid from Tim Berners-Lee project started out at MIT. There's a push there, and it's not just for machine perception data and for AI models. It's there's a push towards that kind of new generation of decentralized data store for exactly this reason. Now, the potential that data store is something physical versus it's not owned by one corporation, but it's accessible by any corporation you want to give access to, I think is a good question. And then we don't know what the right model is there, either from the business point of view or even technically. But on the technical side, there are limitations if that data does not sit on a physical device that you can take with you. So whether it's a home-like pod or it really is some sort of mobile phone that has those models on, and they are transferable. Not sure. There's deep research that's needed there on building models that can be transferred. And the other kind of the connected topic is with federated learning as a sort of like a mechanism for enabling personal data to be used in aggregate but in privacy preserving ways. Even that becomes problematic when the data stores themselves that may be used are massive and cannot be efficiently uploaded. So in the end, you may move the model to the device rather than the data to the sort of like the aggregation point. And so within the federated learning paradigm, that kind of shift is also going to be very important. Just as a recall, Project Aria produces on the order of 18 gigabytes of data per day in compression. With the settings that were shown, tens of frames per second, so not that high frame rates. That data can't be shipped off device to, live somewhere and be processed later. So it will be important to hold on to that in a personal data pod of some sort. Yeah, Armin.
I guess, Richard, you touched on this topic, but just wanted to make sure that there is. You can technically decouple physical storage from storage, meaning that you can encrypt stuff. So if you trust encryption, then you can that would be an easy way to move stuff out of the device, and only you will have access to it, even though it's physically somewhere else. But if you're concerned about actual physical storage, then decentralized approach, Richard mentioned, or having a third device, that should solve the problem.
Yeah, the only concern I was kind of having is even if you allow user to download the model from one device to another, then there is a huge possibility of hacking. And then that is another area in itself. So yeah,
absolutely. Data sitting on the memory is also susceptible to hacking. If you heard about Rowhammer, for instance, you can read it from the memory by running something else. So those physical attacks are available anyway.
Okay.
I'll just add something too. So I think we talked about the personalization of data, right? Ownership, transparency, and power over your own data. But there's also a part of this which is relevant for the systems and the models that we want to run on these future perception, services. I talked a lot about object indexing with the idea that we want to query this model. And even at that level, how you query a model is a pretty personalized thing, right? When I say, where's an apple or something? I might be thinking of a very specific apple at a specific ripeness, which is very specific to my own taste, right? So we get at a pretty deep level of personalization all across, right? Software, hardware, everything. So that is a big focus. I think that's kind of where we see a lot of the future of this is, let's try to tackle a unified model of the world in the semantic sense first, and then be able to, with new data, which is personal to your experience and new input from the user, right? Having the user in the loop, then we can actually have these models be personal as well.
Sounds good. Thank you.
First of all, thank you all for organizing the fantastic tutorial and the open source data set. So I was early in the Ego4D workshop today. So I have kind of like a confusion, like what's the main difference between this data set and the Ego4D data set? Because I think they are both egocentric video-based data set, and I think they also share some same research problems. So I kind of want to know what's the different focus of the two data sets and what's the new challenge presented in this data
Yes, and do we have the device with us? Yeah, just grab an Aria. So at a very quick level, number one, Aria is not a data set, it's a device.
Yeah.
And so that means you can generate lots of different data sets that are not in Ego4D. We also are a main collaborator in Ego4D as well. A big differentiator, so I'll just go through a recap and may trigger some other questions. Aria has, number one, eye tracking. So you may not yet be interested in eye tracking in the egocentric space, but it's really a dominant feature of humans that are fortunate to have sight, that actually this is a great indicator of their intention, attention. Spatial microphone arrays, so whoever got their hands on one of these devices will see tiny dots all over it. It's got 7 microphones, and that allows us to distinguish the sort of the egocentric personal sound versus so you've got basically big differences in that capture. And then you've got basically this fundamental capability that we were just talking about, which is this device has the ability to have very high accuracy trajectory estimation, very high accuracy, so sub-centimeter, sub-degree accuracy, and the alignment in space and time. So if there's 2 people with 2 Arias, their data sets are time and space aligned frames. And that's very difficult to get from GoPros. In fact, if you've ever tried to time align, for example, sequences from videos, either from your mobile phone or from higher quality cameras, they will drop frames, or through compression, the time base will drift. And you may think a thing is in sync, and then about 3 minutes later, it's out of sync by seconds. And Aria allows for synchronization at sort of like certainly around the millisecond level without too much trouble. We'll say that. So this is important for a lot of research where the signals between, for example, audio and visual actually require very precise sound. So when you touch or drop an object, and your microphones are sampling at say 22 kilohertz. Actually, there's a great amount of signal there about the fact that contact was made, but your frames in your video sequence may be sampling at, say, 10 frames per second. So there were some talks earlier in the day from Xiaoyang who showed that basically we can sample the sequence of the trajectory continuously. So it's not even a discrete pose, it's a continuous trajectory. And so then you can align images very accurately with where they were in that continuous pose with, for example, microphone arrays. So for true egocentric, with humans at the center of them, this is a very different class of data set that can be generated.
Or do you want to?
You can go ahead.
Yeah, I just want to underscore that what we're releasing here is a pilot data set. Ego4D is a much larger data set, right? 3,000 hours versus about 7 hours that we've released. And Ego4D has amazing tasks and benchmarks for very important egocentric tasks. So I'd recommend if you guys haven't checked out their task decomposition, it's very, very insightful. And then the data that supports that data set really shows, what is the domain that these tasks, are very, very relevant on. So there is some overlap for sure, but I totally agree with the point. This is a research device, doing things like that BMW collaboration, multi-users in the same space, or other devices, in the future. That's kind of a big focus and a big power of the Project Aria device.
Cool.
So I think I just try to highlight a few points is internally when we try to design what the pilot data set should look like when we release, and we actually have very strong points which we want to sell, which is so different from Ego 4D, which is a phenomenal large effort to collect of all the videos which you know already. This is GoPro videos, it's music videos, it's YouTube videos like, but in an egocentric form. Everybody understand what kind of video, you understand the concept. And people working on video retrieval, recognition, you apply your method over there and solve some of the tasks. They give you some specific task setting, you can drop in and do it. So, but like at least when I studied this, and what we really trying to emphasize a few points is that, so what is missing and what is the additional opportunities that people should pay attention to, which Project Aria device can provide. So in that sense, we're trying to highlight showing all the capabilities that Project Aria devices have, for example, to really have the multimodal information over there, but also trying to not to sell you a benchmark. Like we specifically trying to ignore the benchmark side that we don't want you to solve absolute memory. We don't want you to solve object detection because the potential of the future AR and with all these multimodals and how the task should be look like is unknown. It's up to you to define. So we just hope you can focus on understanding where we are now with the devices. When we're talking about multimodal, what does that mean? What is multimodal? It's not just video plus audio, is a lot more information. And with eye tracking, with all the IMUs and with all the position information, people might not be aware that, oh, we actually solved it. Actually, yes, we did solve it. So basically, you have this information there. So you should, I think it's this opportunity, I think we're trying to get the data set to have people to really have a glimpse, look at it, and to think about, oh, can I solve the research differently? I mean, it's a different focus. It's a different task, actually, we can solve now rather than solve a video retrieval task or two. So, I think the point really is trying to inspire people to look at it and then give us feedback. That we do have bandwidth to support the open research. We have the strong initiative. We're also doing all the kind of exploration, but we also need people feedback to tell us, hey, like also some diversity of different opinions. What should be more important? If we focus, what should we? If we collect more data set, what does people need, right? And so these are other things which is actually the true research. So we want people to more thinking on that aspect. So if you want large collection of video, Ego 4D is phenomenal. You can do video pre-training for all of that. I think it serves a great purpose for that. It also serves quite strong tasks on that. But if you want a different, like basic glimpse of what the future might look like in terms of multimodal sensing, what capability we'll have, what kind of new research you will have, this pilot data set might give you the initial preview about and then to begin some thoughts. And if you need more help, just let us know and we potentially can help. Yeah, so.
Great, yeah, thank you for the answer and thank you for the efforts.
Yeah.
I have a follow-up question. So because the project is really centered on the device as you trying to emphasize. So when do we expect to see the next version of glasses? And they may have different IMU, different cameras. Do you think the research we have done and the data set we collected for this version of glasses can be transferred or useful to the next version of AR glasses?
Yeah. Project Aria is really the tip of the iceberg, right? Today what we are announcing is a pilot data set that you could use and also request for these Aria glasses so that you can collect your own data set and start to do new types of research and collect data set in the domains that you want to do research in, right? Now, this is just the start. We will be expanding the program, right? So I cannot announce, any new hardwares at this time, but this is really the start where we are, opening this up for open research across the world to contribute to this effort and improve the state of the art in machine perception and AI.
Okay, yeah, thank you for the answer.
I think there's one final note, which is, I don't know about you, but as the questioner pointed out, Ego 4D is going on, this is going on. There's several other related tutorials, workshops, and of course a lot of papers this year that are starting to use egocentric data in the forms. We are at the beginning of a shift in computer vision and AI research away from internet scale, World Wide Web, historical data. I mean, it's not going away anywhere, but towards always on egocentric machine perception and AI. And we can tell that because, I mean, here we are with 2 simultaneous tutorials going on around like egocentric data. Now, when I look at this, and my background's from robotics and robot vision, there are many parallels between the AR, the VR, the wearable AI. The wearable AI, by the way, doesn't mean just glasses. It means like on your wrist and in your earpods and so on, an ecosystem of devices. There's overlap and there's differences. And some of those overlaps, are in thinking about computer vision, machine perception, inference in 3D. But there's actually a lot of differences, and they're around, for example, the very much unique and private data, and how to do research within a paradigm that is respectful of everything we should have learned over the last couple of decades of how research has been done on people's data, internet scale data, etc., especially in computer vision. And realistically, it's this opportunity to shift towards a concept that simply processing a single frame isn't going to cut it for useful AI. Simply, a simple query on, an image is not what we're talking about. We're talking about continuous online learning, and this is the right space and the right paradigm, the right data streams to do it on. It is the data that matters to you, so it's the data that will matter to the AI. So in that respect, we're at the tip of the iceberg, and this is the first kind of data set release, but actual physical devices that we can start to interact with the public, because it has to be very much an engagement between the academy and industry, in many industry partners, to push basically away from what has been the historical regimes for computer vision. And even language, etc., and see the combination of these in this full egocentric multimodal setting. So the opportunities for brand new research is pretty clear. I think one of the questions is what's left? And it's like, actually take everything and just look at it anew with this type of data. It will come out. If you've never seen what head motions do to videos, just take a look. And a lot of things do not work out of the box without some amount of tuning, or in this case, as Julian was showing, the great new work that we've been working with FAIR on, there are opportunities to do effectively low shot, no shot transference, but actually the sneaky thing that was shown in here is the fact that we take those 2D detections, 2D image detections, and we fuse them into 3D, so that the SNR of detections in 2D actually gets boosted very, very quickly because of consistency. So all the 2D techniques that only needed to get, needed to get beyond 95, 96, 98, with respect to their MAP or whatever it is in the current measure. In this case, it's actually what matters is consistency, and so you may fail to detect in this moment because it's, occluded or it's noisy or, motion blurred, etc. But actually you've got another chance, and that's the shift in mindset, how to do research where that is the predominant mechanism versus sort of like an add-on. That's where the fertile ground is for all of us as researchers. So thank you very much, everybody, for joining us. And I hope we get to mingle and have conversations. Otherwise, contact us, bombard us with emails on that address. And we'll love to answer any further questions. Thank you, everybody.